Hi, I'm Siva Idupuganti. My colleague Vijay Tinanur and I are program managers from the Azure Networking Group, and today we're going to talk to you about how you would secure and monitor your network on Azure. So, if you ever had questions about is security really important when I'm trying to develop applications, well, you have to rethink about that question. Today, cyber criminals have evolved, their attacks have evolved, they have immense amount of resources, and their attacks have gone more sophisticated, and they've in spite of the amount of security large enterprises try to put in place, they're always being breached, and there's a huge amount of financial impact. The other fact which a lot of people talk about is it's not just about the large-scale organizations which are being impacted. If you see the report in UK, about 60% of the small businesses have been breached in 2014. There are other fun facts which talk about what are the impacts of security breaches based on a few reports we have seen. Now, let me talk about what Azure networking provides you to empower how you can secure your network infrastructure. I'm not going to touch about how you would secure your, I'm not going to talk about the physical security or the data center security or the data security, application level security today, but my focus is going to be totally on how you would secure your infrastructure from a networking perspective. And these are the products which we today have in place, which will empower you to secure your network. Let me talk about each one of them in detail, right? So this is about virtual networks. Virtual networks are the core concept of how you would deploy your resources or applications onto a cloud provider like Azure. It gives you your own virtual private cloud, which is totally isolated from all other deployments on Azure. And you can have further segmentation of your virtual network into different subnets. You have all your virtual machines can be addressed using private addresses which are not even reachable to any other customers or other internet users. And you can bring your own DNS server if your deployment requires that complexity. But the important fact here is virtual networks provide you that isolation boundary for all your resources on Azure. And once you have set up this isolated environment where you have all your resources built, now you would want the traffic which is coming into your isolated environment to be filtered. Excuse me. You would use something like network security groups and ACLs, which enable you to lock down at a subnet or a VM virtual machine level. Here you see the customer one has preferred to lock down all his subnets, and since the specific VM is receiving traffic from the internet, he could choose to have some additional configuration at a VM level through network security groups. The customer 2 has a deployment where the VMs are receiving traffic behind a load balancer, and all the front-end VMs might have different security rules compared to the back-end VMs, which are his application or database VMs. Once you have set up the virtual network and built all your security groups, you would want to have a better connectivity into your network rather than going through the public IP address if you want to filter bad traffic. I mean, assume your employees are sitting in an informal environment like maybe Starbucks, where they're trying to use a public Wi-Fi, and if they're trying to connect to your public-facing services through it is not secure as you think. The best way to use it is through VPN, and we have several ways in which you can connect into your environment on Azure. You could use point-to-site connectivity, which gives end users connectivity through certificates. And if your organization already has some VPN devices, you could use site-to-site VPN connectivity. And some large-scale enterprises would prefer to use ExpressRoute because that gives them exclusive connectivity into Azure resources without going over the internet. So that is a feature which a lot of enterprises are taking advantage of today on Azure. Now, we talked about all the different features of isolation, filtering, and secure connectivity. And this is a typical enterprise application design on Azure. You see here the customers generally reach out through the load balancer, go into the front-end subnet, and all the resources on the other side of the red line are the DMZ, the demilitarized zone, which have internet-facing resources. And on the right, you see the backend with the app subnet and the database subnet hosting the resources which perform that specific function. You could also choose to have a web application firewall to monitor and inspect all the traffic coming out of all these subnets. That's again an optional setup. And then you have a secure connectivity through VPN to either your own environment or through the remote workers. Now, let me take you through a demo of how you would set up your network infrastructure and secure it using Visual Studio. We talked about a typical enterprise application architecture just a couple of slides back. Now let me show you how you can model that entire architecture within your JSON template. Azure allows you to define all the resources and deploy into Azure using an JSON template. It's referred to as ARM templates. There are multiple ways in which you can deploy to Azure. You could use PowerShell or CLI, but today I'm going to show you how I've set up my project in Visual Studio to do an ARM template-based deployment. Just to give you some context, this is how you would create a new project in Visual Studio. You create a new project, go under Cloud, and select the Azure Resource Group type deployment. And I've already created that project here. You need to have the Azure SDK installed to make sure you can get this deployment project. See, this is the template which you're looking at contains all the resources which are required to build that enterprise application. Here you see the definition of the virtual network under the resources section. And you see that we have defined all the list of subnets which are part of the virtual network. Like we talked about, this virtual network gives us the isolation, and the subnets give us the segmentation within this network. There is a front-end subnet, there is an application subnet, and then back-end subnet. The interesting thing to note here is we use variables to make it a modular design rather than having to hard code everything. Next time I change something, I could just modify the variables and I could get a new template when I need it. I will not get into the details of how you would author Azure Resource Manager templates, but it is interesting to note that you have parameters and variables apart from resources to simplify how you build your JSON template. And this is the definition of a network security group within the JSON template, and it has a name and a set of security rules which specify the type of traffic which is going to be allowed in or allowed out of this of the subnet where this security group is going to be associated to. The definition of where this security group gets applied is again back in the virtual network definition under this subnet. So you see this is the definition of the subnet, the front-end subnet, and the corresponding network security group which is going to be associated with the subnet is defined here, and the specific rules are again here. You see here we talked about a DMZ based setup where you would allow specific traffic incoming into the front-end subnet. You say you allow RDP, you allow HTTP, and from these are all the inbound allowed rules, and from the front-end subnet you have access back to your app subnet, and again you are supposed to be adding specific rules to say allow HTTP and allow 443 because that's where my application subnet servers are running. Now let's say all this, you have defined all these resources in this template, and once you have done so, you could create a deployment right from here. Or Visual Studio has some other beautiful integrations where I'm going to my Visual Studio, the project, and here in the build definitions, I have already created a few build definitions here for my environment. I'll quickly show you the stage build definition I have here. I click edit. Let me minimize my screen so that you can see the definition more clearly. So this definition has just one step. It says create a new Azure Resource Manager deployment into this resource group in this region using the template I specify here. This is the template which we have defined all our resources, and using the parameters file which again has been checked in. You could override the parameters. I'll quickly show you the parameter file here, and these are the parameters which we already have defined in the template, and here currently we are giving out the values for each of these parameter variable. And now once I have defined this build step, I've already saved this build step, and I've enabled it such a way that whenever I do a check-in into my repository, it initiates a new build. So I've already done some check-ins, and this is my stage environment in Azure. So all these check-ins have created corresponding builds, and they have there were some failures which made sure that I could go modify the changes I did to my infrastructure definition in code. And let me show you the current state of the resource group in Azure. So here I'm showing you the build 16 multi-tier service stage resource group. This is the resource group view, which shows all the resources which are part of the resource group. You see here it has an multi-tier VNet, the line which I'm selecting here, and it has all the definitions of subnets and the devices which are part of that virtual network. And you have the actual VMs which were defined as resources in the template. And it also has the network security groups. So let me show you the network security group rules which are defined for the front end. We went through that as part of the JSON template. Let me show you the inbound rules. These are the inbound rules which we've shown in the JSON template. These are the outbound rules which we have set up in the JSON template. These are a few, I have recently modified these rules in my stage environment, and if I show you the corresponding view in my production environment, it still has some old rules. I was trying to make sure all my rules work as expected in my stage environment. Now I'm ready to trigger a new deployment into prod. So I go to the prod definition, which I've already created, and I queue a new build with the latest version. And this, when it completes, it should modify the outbound security rules to make it look similar to how the stage environment looks. Now, just to recap, what we are trying to show you here is you could define all the resources you would need for your infrastructure within this JSON template. You can now own and control the entire infrastructure which will support your application deployed on Azure. And because you can control this as you would control and manage this as you would manage all your application code, it has all the benefits of going back to a known good state, testing all your changes in stage, and then rolling out into prod. You get all the benefits and you can apply all the DevOps principle even to the infrastructure which is going to support your environment. So we have shown that infrastructure can be managed similar to your application code, and the networking, all the networking functions and the products which we have shown to enable you to secure your environment can be managed from right within your familiar Visual Studio interface. Now let me go back and see the status of my deployment. Looks like it just triggered one deployment, but let's give it a few minutes before it can actually run. This is a previously run deployment which I'm showing you on, I'm trying to show you on the stage environment, and then it completed successfully, and that's where I've got the new rules. So let's see where we stand on the deployment here to the production build. Looks like it just triggered a new deployment to our production environment. I'm going to check the status of the production environment here. I see that it is deploying. I see that most of the changes are already applied. So let me go check the status of my resource, my network security group, and see if my corresponding changes are done to my production environment. So I go to my outbound security rules, and there you go. All the HTTP, HTTPS, and readers rules which I have defined and which were successfully verified in my stage are now in my production environment. There you have it. So you have seen how you could use Visual Studio integration to manage your infrastructure. And these are some references on how this entire demo was built. You could find a lot of Azure ARM templates up here in one of the links here. You could see how the Visual Studio integration can be really set up from end to end. You can find all these references up here. Now, let me hand it off to Vijay Tinanur to talk about monitoring.
Hello, everyone. Thank you for joining us in this session of securing and monitoring your networks on Azure. I think Siva gave a fantastic presentation on how it is important and pivotal to secure your networks and your investments in Azure. I'm going to talk about why is monitoring more important. Why even talk about monitoring? What are the needs for monitoring? Well, there are three pivotal factors, if you will. Number one is malicious operations. You want to ensure that whatever assets you have, network resources that you have in Azure, are going to be provisioned only by people who have the intent to provision it in the right way possible. Second most important thing is about customer experience. So as you would know, a slower network or a slower application is not going to give your customers a lot of satisfaction. So it is important to understand and address any service degradation that can be caused due to the network, be it latency or bandwidth or other faults that can be. The third important aspect is about operational excellence. So as you grow and scale, it is important to understand your capacity needs and how can you really plan for those capacity needs. So it's important to monitor your assets in networking in Azure. So let's talk a little bit about how does this all look under the hood. There are three main aspects. Number one is the network resources. So if you talk about networking in Azure, it's all about software-defined networking, and all the resources are basically software implementations or abstractions. And all these resources continually emit log based on various conditions and parameters that are set for within. The second aspect is about archiving these logs. So this is where we send these logs to customer-defined storage or customer-selected storage. And the third aspect is about ingesting these logs and trying to make some information out of it. And such ingestion can happen in two channels. You could either use a third-party application to ingest these logs and visualize what is happening in your network, or you can use Microsoft's technologies. We provide a wide array of tools that give you various insights based on data. You could use Operations Management Suite, or you could use Power BI. You could also use Azure ML and HD Insight as well. So you do have a very good flavor of how you can generate these logs, archive these logs, and ingest these logs for better visualizations. So talking about logs, we have primarily three categories of logs. We have audit logs, we have control plane logs, we have data plane logs. Now, audit logs are primarily logs that are emitted when you're having an operational event that the operator performs via ARM. And it includes details like the time of operation and who performed this operation, what operation was performed on what resource, and what was the status, and so on. Talking about control plane logs, let's say you create a provisioning action on, let's say, setting up a network security group. So that information gets logged as well. And the so-called state is also emitted periodically so customers can understand what is the state of this operational action in the fabric. The third important aspect is data plane logs. Logs that are periodically emitted to understand the data plane performance and operation as well. As an example, if you have network security groups that are set on a subnet and you would like to understand what are the flow and deny counters periodically, then there is a way for you to go enable such logging and get this logging put in your storage that you can ingest later on. Such logs will enable you to understand any abnormal events that are happening in your network. For example, if you have a lot of deny counters going very high, there's a very good likelihood that there's some kind of a malicious operation that's happening within your network. So we talked about why monitoring, we talked about the various categories of logs, we also talked about the infrastructure of how logging looks like. Let's talk about the primary areas of focus in monitoring. Number one is you will want to monitor as you are provisioning anything in your network, which is about auditing your provisioning actions. The second important thing is about monitoring your operational performance in your network. Your network is operating as usual, but you want to make sure and ensure that it is being monitored continually and the logs indicate that your network is performing as desired. The third aspect is about getting additional insights. When you have all these logs that are emitted, you want to be able to ingest these logs and see if you can get further insights from these logs in terms of network performance. So let's move further ahead and look at some good demos here. We're going to start looking at some demos for monitoring operations in the network. So we're going to see a couple of ways on how you can go and monitor your audit operations. Let's see something quickly here now. I'm going to resource group. I'm going to get the demo resource group, which I've been using for a while now. And I'm going to go to audit logs. You click on audit logs here, and you should be able to see the operations that were performed on your network resources within the resource group. And I have to just scroll down to see what the operation is. And if I can click on it one more time, and I can also see more details of the operation. Here you go. So what resource was operated on, and what was the resource URI, the subscription ID, the timestamp of when it happened, and the resource group as well. So it does give you a lot of details. So this is one way by which you could do this monitoring of audit actions. Now there's another way you can do the same thing. You can go to PowerShell as well. So I've got a PowerShell ISC that has been set up. I can execute a PowerShell command to go look at a resource group at a particular point in time. Now I'm just going to execute this and see what really happens. There you go. So you do have a sequence of events that have happened in the recent past. Here again, you get a lot of details. So you get the action that was performed, who performed the action, what was the subscription ID, what was the resource group name, and so on and so forth. So this should give you a lot of information in terms of understanding who did what operation at what point in time. You could also use Azure alerts that we'll be seeing very quickly now. So we did see a couple of quick demos on how you can go and monitor your operational actions. You could either choose to sit down and look at the volumes of logs and figure out when a particular action happened and who performed that action, or you could use Azure alerts. With Azure alerts, you have two primary contexts. One is to set a role, and one is to set an action. A rule gets triggered whenever a corresponding log event happens, and an action is triggered whenever the rule matches that particular action and you want to take an action for that particular role. As an example, let's say if you have a person who's modifying virtual networks and you would like to get an email whenever somebody modifies the virtual network. So in this case, you would set an Azure alert with a rule which says that whenever an operation happens on this particular virtual network, please give me a trigger. And the action could be either an email or a webhook. Now with email, you would get an email notification. With webhook, you can integrate with a third-party application. Such applications can either send a text message, or it could be a messaging application like Slack, which you could integrate with. So we talked about Azure alerts. There are two primary contexts in Azure alerts. One is to set an action, and one is to set a role. So with the role, you primarily can say that anytime an action or an operation occurs on a resource, you would like to get a trigger. And the trigger primarily says that you want an email, or it could be a webhook. In our example here, first we're going to start with a webhook. So I'm going to execute this. Now you basically indicated a trigger action, and then now I'm going to execute this command, which basically adds an alert rule. This alert rule is anytime you go and modify a virtual network in a resource group called demo in WestUS, you should get an alert, and the alert is going to be an email. You could also use webhook instead of emails. That's your choice. So I'm going to go back to my demo screen, and I'm going to add a virtual network, and you should be getting some triggers. I'm going to give it a name of test 5, and it's the resource group demo, and I'm going to create, and you should get a create success complete quite soon. So we did receive an email for the alert that we set earlier, where I was creating virtual network test 5. The email also gives you a lot of details about what action was set. I'm just going to scroll down. It gives you the resource URI, it gives you the subscription, it gives you the properties. So this is pretty good. And you could also tap in here, and this will take you right into the Azure portal. So you can see the efficiency with which the alert gets created and how a user can react to this alert and take corrective action. So in the previous section, we talked about monitoring your audit operations. Now we're going to talk about how you can monitor the operational performance in your network. A couple of avenues are currently available today. One is you could use a diagnostic log browser. As an example, if you are having security counters and you want to enable logging for security counters, you could do that today. And what is more important is that you could either ingest those logs and use a third-party tool for visualization. For example, you could use something like Power BI to visualize the logs, or you could also use a log browser that happens to be available today. And with the log browser, you can get instantaneous look at what are your logs. Or you could use other Azure services as well. For example, Azure Automation. With Azure Automation, what you could do is you could basically call or make a workflow, and this workflow can do a constant polling of APIs where you are going and checking for some action of a connection state. So we're going to see a quick demo on how this works. We are now going to look at how you could use Azure Automation to do your monitoring operation as well. So I have an automation account, and I have a demo set up for you as well. I'm going to bring up this runbook. And we are going to edit this script to see what it really contains. I have this script called Monitor Network. Now, if you go into Monitor Network, what it's really doing is primarily there are two different VNets, and you have a VPN gateway that's connecting the two VNets. And the script is essentially checking for connectivity between the two VNets. So we are calling the URI to basically get the connection status. We are parsing the results to understand whether the status returned is connected or not. If it is not connected, you're basically sending a message to yourself saying the connection is down. So we are going to publish this, and we're going to run the script. So when you click on start, the runbook is executed, it gets queued and it gets executed, and momentarily you should get the results as well. So it looks like a job is now completed. I'm going to click on the output to see what it says. So yes, as you saw earlier, we were checking for the connection status, and the connection is connected indeed. What you could also do is you could go and set the schedule for this particular job. So I click on schedule. There's already preset schedules here. I have a schedule that can be run every 15 minutes, and which will go and check for your connectivity. All I have to do is to turn it to on, and that would start working. So we talked about how you can go and monitor your network operations. What is also important for users is to go and look to see if they can get additional insights from these logs. Let's try to get a quick demo done on that. So what I have here right now is trying to use Project R in trying to detect anomalies. Let's assume that you have a network, and the network is constantly emitting logs about your network security groups. Let's assume that you have a malicious user who is primarily punching through a hole in your network and trying to transmit out data. And if that person is going to do this kind of operation every once in an hour, it's very difficult for you to detect. So what we're going to show right now is about an anomaly action that is happening in your network where somebody is punched through a hole over a period of about 15 days or so, and how you can really detect such actions. So without further ado, now we're going to be using Project R to detect some anomalies that can happen in a series of logs. What we have right here is a sequence of logs. These logs are primarily security rules that were applied on your fabric, and is being tracked over a period of, let's say, 15 days or so. And we've got close to about 50,000 events that were generated. And what this source is going to do is primarily look at the sequence of logs, and it's going to be generating some anomaly patterns. This should take about a minute or so to execute. It's looking for basically correlation across various log events and each log row, so to speak. So what you see right here is basically an anomaly that has been detected on 3 separate incidents where someone has changed a security rule where an outbound access was allowed from your network, essentially create a problem. So we saw 3 important things about monitoring. Monitoring provisioning actions, monitoring your network performance, and also be able to get additional insights into how your network is operating. Here are a list of references for you to go look at and get more insights into what we can do with your network monitoring. So summing it all up, with infrastructure as a code, you have the power to write the code when you want to, deploy it, and manage it. But with that empowerment also comes a very important aspect. You have to secure your network infrastructure. That's very fundamental. Besides securing your network infrastructure, it is also important for you to monitor your network to enable a good customer experience, protecting your investments, and enabling operational excellence. Thank you so much for joining me and my colleague Siva in watching this session.